First, how the discrete signal is represented. Okay, so just I'm writing this discrete signal, a discrete time signal. It is basically a sequence, right? It is also known as a sequence xn, right? So it is defined only on integer, right? Only on integer value of n, nothing else, right? So let's say xn is I'm writing. So let's say this is the infinite duration discrete time signal. Let's say this is x minus 3, x of minus 2, x of minus 1, then x0, then I'm writing x1, then x2, then x3, and then dot dot dot. Okay, so this is the the discrete time infinite, you can say the infinite duration. So it is the infinite duration discrete time signal, right? So okay, so what is the value? Okay, so this arrow represents this arrow, the arrow where this is pointed here, at this arrow is pointed here at the x0. So it will start, the arrow will only denotes the value of signal xn at n equal to 0, nothing else. So at n equal to 0, the sequence will start from n equal to 0 from here. Okay, so this is from the negative side, this is the positive side, right? So you can see like this is the 0 and this is the negative side, this is the positive side. This is x of minus n, however this is the xn, right? This is the x0, nothing else. So if the xn can be represented in the infinite duration time, let's say this is the minus 2, this is the 1.3, this is the 2, okay, this is, let's say, minus 3.4, this is the minus 1, this is the 2, this is the 1, comma dot dot dot. Let's, and I'm representing this, the arrow is here. Let's say the arrow is here. It means your n equal to, the sequence at n equal to 0 is this one. This is the n equal to, sorry, I'm not going to give the arrow, otherwise you confuse it. So this is the n equal to 1, this is the n equal to 2, this is the n equal to 3, this is n equal to 4, right? This is n equal to minus 1, n equal to minus 2, and so on, right? And so on. So what is the value of x of minus 3? X of minus 3 0. What is the value of x of minus 2? This is minus 2. Okay, what is the value of x of minus 1? So you can say 1.3. What is the value of x0? What is the value of x0? Okay, so you can say the value of x0 is 2. The value of x1 is minus 3.4. x2 is 2, sorry, minus 1. Okay, x2 is minus 0, 1, 2, and x3 is 2, x4 is 1. Okay, so this is the case. Now come to the next point. So this is the infinite time duration, discrete time signal. So when you represent, now what is the finite? It means something is there, the finite time, finite length, okay, finite length duration signal, you can say. So what is this? Okay, so such type of signal is limited between, let's say this is the n1 and n2. So this sequence is limited in between the n1 and n2, right? However, the infinite duration signal is limited in between the from the infinite, minus infinite to infinite, nothing else, sorry, minus infinite to infinite, right?
Sir, hello. Hello, sir.
Yes.
Sir, Aditya Kumar here.
Aditya.
Sir, सर हम सब क्विज दे सकते हैं सर, पर क्लास नहीं हो पाएगा। क्लास नहीं लगा सकते हैं सर, क्विज दे सकते हैं।
देखो it is unofficially, I'm assuming it is it is mass bunk, but if you want to learn, then it's okay. It depends only on you. If you want to learn, otherwise you can learn, otherwise no problem.
यस
You can
सर,
ask.
हम क्विज दे देंगे सर।
हाँ क्या? Sorry.
सर हम क्विज देने पे रेडी है सर, एंड विल गो थ्रू लेक्चर्स, कल वाला एंड आज वाला भी सर, और हम उसके लिए प्रिपेयर कर लेंगे।
ठीक है Depends on you. I am not compelling you, है ना? I know the matter you are facing, है ना? कोई प्रॉब्लम नहीं है, आप लोग उसको देखो।
सर एक्चुअली हमारी प्रॉब्लम सर स्टडीज से नहीं है, लेकिन वो फिर हम अगर 8-9 घंटे स्क्रीन टाइम देते हैं तो सर जो बाकी हमें जैसे कोडिंग करना है, किसी ने मशीन लर्निंग करनी है, तो उसके लिए फिर टाइम भी नहीं बचता है, मतलब वो बॉडी थक जाती है, तो मतलब लैब्स में सर 2 घंटे टाइम कम कर दे, तो ये सारे इश्यूज ही थे सर, तो कंबाइंड।
कोई नहीं
प्लस अभी आपको पता होगा कि अभी 3rd ईयर से गेट भी अलाउ कर दिया, तो बच्चे उसकी भी तैयारी करें, तो उसको टाइम उसके लिए भी उनको जैसे ऑनलाइन लेक्चर्स देखने पड़ते हैं, क्योंकि ये स्पेशल ट्रिक्स भी सीखनी होती हैं, तो वो फिर ऑनलाइन लेक्चर से पता लगता है।
बिल्कुल
उधर भी स्क्रीन टाइम इंक्रीज हो जाता है, तो सर उधर भी स्क्रीन टाइम इंक्रीज हो जाता है, प्लस 7 to 6 आवर्स इधर हो जाते हैं, तो सर आंखों पे बहुत ज़्यादा प्रेशर पड़ता है और हेडेक भी होने लग जाता है, तो फिर वो बहुत मुश्किल हो जाता है सर। इसलिए बस चाहते हैं कि टाइमिंग कम हो।
ठीक है, तुम लोगों को जेन्युइन प्रॉब्लम है, नो प्रॉब्लम, इट्स अ जेन्युइन प्रॉब्लम, बट ठीक है, तुम लोगों को जो तुम लोगों को ठीक लगे प्रमोद, नो प्रॉब्लम फ्रॉम माय साइड, है ना? ये मेरे तरफ से कोई प्रॉब्लम नहीं है। इफ यू वांट टू लर्न यू कैन अटेंड।
आपका जो लेक्चर वो देख।
सर एक्चुअली हम डेली अटेंड करना चाहते हैं क्लासेस, ऐसा नहीं है, लेकिन सर वही प्रॉब्लम इतना आ रहा है, और सर एडमिनिस्ट्रेशन को जब हमने मेल किया तो सर इतने सारे मेल किए, एक भी मेल का रिप्लाई नहीं आया सर, पूरी तरह से इग्नोर कर रहे हैं सर।
अच्छा, तो I have already sent the yesterday mail to the head of department and the higher authority, and today again I will send the same mail to him, just because the students have not attended the class and he has marks bunked due to the demand is to reduce the lecture hour and the lab hour also, है ना? Have yet I have uploaded the lecture on the core class, so कोई प्रॉब्लम नहीं है ना? तुम लोग मेरे जो मैं तुमको कह रहा हूँ वो मेरा अपना ड्यूटी कर रहा हूँ, यू कैन डू योर ड्यूटी, है ना? इट्स योर डिमांड, ओके? सो इफ यू वांट टू अटेंड, इट्स योर चॉइस, अदरवाइज आई डोंट कंपेल यू, ओके?
सर वही बात है सर, एक्चुअली ना मतलब ये लेक्चर टाइमिंग कम करने वाली बात तो सर पढ़ाई नहीं करवाना चाहना सर, इससे कम वो मतलब मिक्स मत करना सर। एक्चुअली एडमिनिस्ट्रेशन वही करता है कि मतलब वो कहता है कि नहीं आप पढ़ना नहीं चाहते, इसलिए आप मतलब ऐसा कर रहे हो सर। ऐसी बात नहीं है सर, हम पढ़ना चाहते हैं सर।
बिल्कुल, इसमें ऐसा नहीं है कि सारे बच्चे ऐसे नहीं है, मैं उसमें सबको नहीं लेता, है ना? लेकिन 6 आवर 8 आवर कंप्यूटर पे बैठना, कंप्यूटर स्क्रीन पे बैठना, इट्स नॉट अ वेरी इजी टास्क, or especially for the BTech students. So I'm also not recommended to all the BTech students to sit on the chair and to computer and for the last 8 hours and 9 hours. It's a very bad, it's badly affect on your back also, है ना? Back, neck, it's a problem, तो eyes पे problem तो करेगा ही। I am also facing the same problem of the back. I'm still sitting the 18 hours 12 hours on the chair and facing the back problem, and now the neck problem has started. So it's a radiating problem, the pain is radiating from neck to the west nerve, okay? So no problem, just I'm taking my lecture, okay? So if you want to attend, otherwise it's your choice, no problem, right?
Okay sir, thank you sir.
Okay, okay students, okay, no problem. So this is the finite duration signal. So this is the infinite duration signal is like limiting from n equals to minus infinite to infinite. So this is the case. So some signals are there which is the right sided signal as well as the left sided signal. I'm not going into the causal and non-causal type of the signal because I have not yet taught in the class. So right sided and left sided signal, let's say xn equal to 0 for n equals to less than n1. So this one is the right sided signal. This is the right sided signal. However, if you write xn equal to 0 for n greater than n2, then it becomes the left-sided signal, nothing else. Okay. So I'm not going to the right now the causal and non-causal type of the signal. Okay. So the very important operation usually we are using in the discrete time signal. So you can say it is a basic operation on discrete time. We are already handling the continuous time signal. So now it is time to handle the discrete time signal, how the basic operation is employed on the discrete time signal. So first, let's say I am taking one signal, how it is represented graphically. Let's say this is the WN1 signal, and it is the, let's say this is the 1, 2, 3, and so on, 4, and so on. So this is the N. And at another stand at -1, -2, and -3, -4. So all the value is 0, and let's say the magnitude is 1/2. This is the Wn. Now I'm taking the another signal, let's say xn, and this xn is, let's say, again having the magnitude 1/2, having the magnitude 1/2, 1/2 at from like this signal 1, 2, 3, and 4. And let's say this is the, let's say this is the -1, -2, -3, -4. So -1, -2, -3, -4, and so on like this. So this is the xn, this is the wn. Now I want to add, we want to add the signal with let's say this is the xn, and let's say this is the wn. And now if you add these signals, so what we'll got, this is a problem. So you can easily you can conclude with the help of the uh, continuous time signal, such type of problem you have already done. Let's say this is unit step signal, and already you have added such type of let's say this is a signal. So this is a 0 from this side, and this is a -1. So added, and you can say, sir, from 0, -infinity to 0, the value is this one. However, the value from 0 to this is a 1, so this is a 0. So when you add it, this will got the signal. In similar way, this is a 1/2, this is a 1/2. When we add, so you will got 1, okay, and again this is the 111 up to the infinite time value. The magnitude becomes 111 from 0 to infinite, okay, 1, 2, 3, 4. And when you add -1/2 with a 0 from -infinity to 0, then it will again comes only the -1/2, right? So this is the case you can find out with the help of -4, -3, -2, -1. Okay, this is the 0. So but if you anyone ask what is the value of x3, so you can say simply, sir, x3 equal to 1. Okay. Now I am taking one more example in which the xn, this xn is added, okay, with, let's say, an alpha value, and alpha is a constant. Let's say the magnitude is 1/2. So 1/2 constant is added with the signal. So this is the -1/2. Okay, this is the -1/2. So when you add the signal, automatically from -infinite to 0, value becomes 0, because this is a -1/2 magnitude is here, and this is the constant value 1/2, 1/2, 1/2, 1/2. So 1/2, 1/2, 1/2, 1/2, it is like that. Okay. So at every instant the value is 1/2. When you add this signal from -1/2, from -infinity to 0, so we'll got the only the 0 signal. Okay. However, when you add the 1 by 2 from 0 to infinite signal, again you will got the value 1. So this is the case you can find out. So this is the case of the signal. Okay, let's say this signal is yn. Yn is nothing but the xn plus alpha. Xn plus alpha. This, let's say this is the again yn, and let's say this yn is called as xn plus wn, right? So this is the case. Okay, so when you multiply, now see the multiplication case. What happened when this xn plus wn, what happened when this xn plus wn is going to multiply, right? So let's say this, I'm changing the color of the pen, you can understand it. So let's say the some wn is coming from this side, okay, and this xn is coming, this xn is coming, okay, and going into this with the multiplication signal, okay, multiplication signal, then what will occur, what will got? So let's say this is the yn, so xn and multiplied by yn. So this is, case the 1 by 2 and 1 by 2, automatically it will give from 0 to infinite is 1 by 4. However, 0 and 1 by 2 is multiplied, will got the 0 from minus infinite to 0. So we can draw this signal like 0 from this side, okay. However, this is a 1 by 4, 1 by 4, 1 by 4, and 1 by 4. So this is 1 by 4, and okay, this is a 1, 2, 3, and so on, minus 1, minus 2, minus 3. So this is the yn. Yn is multiplied with the xn and wn, right? Okay, now let's say this is the xn, and xn is one more property I'm taking. Let's say this is the scaling property in the xn. So when you take the alpha value inside this, okay, and let's say the alpha is 1 by 2, so yn, okay, so yn, so yn is, what is yn? What is yn? Can I, okay, there is no student, so alpha is multiplying with xn. When alpha is equals to 1 by 2, the constant is 1 by 2, and we are scaling with the amplitude. So can you tell me, okay, this is the 1 by 2 and 1 by 2 is multiplied, so 1 by 4, and from this side also this is the 1 by 2 multiplied with the magnitude, okay. So it will gives the, it will, this such type of signals will gives nothing but the 1, this is the case 1, 2, 3, 4. The magnitude is nothing but the 1 by 4, and this side also we will got the 1 by 4, 1 by 4, 1 by 4, 1 by 4, and so on. So this is also the minus 1 by 4, this is 1 by 4, and this is your yn. So this one is the case you can got. So this is your nothing but the scaling property, scaling multiplication, scalar multiplication, okay. This property is known as scalar multiplication, right? Okay. Now I'm come back on the next part, and this next part is the transformation, okay, or the properties, okay. So first you have already seen the time shifting property in the continuous time signal. So now the time to study the time shifting property in the discrete time of the signal, discrete time signal, how we handle, okay. So again, this is, let's say xn is any signal, xn will be the any signal, okay. It will be shifted, okay, it will be shifted by, let's say, and the independent independent variable, you know, n, okay, n. So what we have to do, this variable we have to shift by n minus n naught or n plus n naught, right? So these are the case, okay, okay, okay. So when now I'm taking this case n minus n naught, okay, xn shifted by, let's say, xn minus n naught. So now I'm taking only this case, ignore this one. Meanwhile, let's say this, just ignore this one. Now I'm saying if n naught is greater than 0, it means your signal is shifted to right side, right? To right side. And it is called as delay. Delay of the signal by n naught, right? Okay. So what it means? It means, in other words, you can say also, it means other words you can so say, if let's say xn, what happened when it shifted to n naught, xn will start at n is equals to whatever the value. Let's say you have shifted at this value, that n, right? So see the case so that you can understand it very easily. Let's say this is the signal xn, okay. Let's say this is the signal xn I'm taking. थोड़ा सा magnitude इसको कम कर देते हैं. Let's say this is the magnitude. Let's say this is the, let's say this is such type of signal is there, okay, and let's say such type of signal is there. Now just I want to write xn minus n naught, right? Where n naught is greater than, you know, 0. So if we write this is a 1 2 3 4 minus 1 minus 2 minus 3 minus 4, it will shift at the n naught point. So this will start by the value whatever the n naught is there, right? So I am taking, let's say this is the n naught, let's say this is the n naught, this will shifted to at this point, this is the n naught, then this value is there, this value is there, then this value is there, then this is there, then this, and let's say maybe it will shift go like this, and this depends on the position, the value of the, you know, the signal, the magnitude of the shift, this n value, okay. So this is the case of the shifting. So this becomes x0, this becomes x0 now, right? In similar way, well, n is not greater than, you know, 0. If n naught is less than 0, then it will shift in this direction, then this will shift in this direction, this will again, this will go to the in this direction, okay, in the case of this, right? So this is the, you know, advancement of the signal when you write this, okay. Next we can solve this problem by xn plus 2, okay, or xn minus 2. So we have already done, so I'm not going to details of them, you can do it very easily, okay. In the continuous time signal, xt plus 2 xt minus 2 we have already seen. So just to try to solve these problems, and you can do. So now I'm taking the time scaling decimation and interpolation, decimation and interpolation. So what will happen with the decimation and interpolation? What is the meaning of decimation and interpolation? Okay, it is a time scaling, okay. So in the case of time, you know, continuous time signal, we have seen the expansion of the signal. Let's say when we write xt, we shifted by x of t minus t by 2. Then we have seen the signal is reducing, and if you're writing 2t, then the signal is expanding, right? So in this case, the decimation is occurred and the interpolation is occurred. What the decimation? So the definition of decimation is, process of reducing. It is same as in we have studied in the time continuous time signal, but here the definition is same, but the terminology is different. Decimation, it is called as. So process of reducing the signal length by discarding. Here we will discard the sample. How we will discard? Right, let's say see one is from example. Okay, so let's say xn is, I'm taking one example and then you can understand it very better. Let's say this is the x of 0. Okay, this is x. Let's say this is x1, this is x2, this is x3, this is x4, this is x5. Okay, in similar way, let's say this is the x minus 1, x minus 2, x minus 3, x minus 4, and x minus 5. And 6, 7, 8 is 0. Okay, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 is 0, minus 7 is 0, minus 8 is 0, right? So this is the case. In similar way here, the 6 is 0, 7 is 0, 8 is 0, x8, x7, x6 is 0, right? So this is the xn. Let representing the signal by xn. Okay, this is x minus 3. Okay, in similar way we can write any signal. Let's say this is the x3, just for the sake of the representation. Now I'm giving one problem. Let's say just to scale the signal, time scale the signal by x of 3n, x of 3n, x of 3n. So what will happen? What will happen? Okay, what will happen? Why? How can it solve? Okay, so what is the? I'm taking I'm describing this with the help of the value. However, you can solve it very easily. But for the point of explanation I am giving you, what is the value of x0? Let's say this is the 1, this is the 2, magnitude, this is a 3, sorry, this is the, let's say 4, this is 3, 2, 1, oh, let's say the 5. I'm doing some wrong thing. So how can it be right? Okay, 5, 4, 3, 2, 1. Let's say this is a 6, this is the 5, this is the 4, this is the 3, this is the 2, this is the 1. In similar way, this is the 5, this is the 4, this is the 3, this is the 2, this is the 1. So what is the value of x0? x0 is 6. x1 equal to x of minus 1 equal to, let's say 5. X equal to 2, x equal to minus 2 is, let's say 4. x3, let's say x of equal to minus 3 is 3. Am I right? And x2, sorry, x4, x4 equals to x of minus 4 is equals to 2, and x of 5 is equals to x of minus 5 is equals to, we have taken, let's say 1 in this case. Now I want to x of 3n. So when you multiply with this 3 and n equal to, when we take the value at n equal to 0, when we take the n equal to 0, then it becomes 0 when you multiply. And what is the value of x0? X0 is 6. When you take the value n equal to 1, then the second value when you multiply it with this, the only the value becomes x3, and x3 is your this value. X3 is 3. What is the value of when n equal to 2? So n equal to 2, when you take this becomes xn, n equal to 2. So 3 into 2 becomes 6. So x6, and x6 is nothing but the 0. In similar way, go to the negative side. When you take the n equal to, let's say, 3, so when you take the n equal to 3, it becomes 9 and 0. And all the value greater than this is again 0. Now, x of, let's say, minus n equal to -1. So when you multiply by 3 and -3, so it gives the -3 value. Okay. So -3 value is nothing but the 3. When n equals to -2, so it will give the -6. So -6 value is nothing but the 0. So your new value x0, x1, x2, x3, x -1, -2 becomes like this. Okay. So what is this? What is this? So this new value may be represented like this one. Sir, x0 is 6. X0 is 6. However, the first value x3 is now 3. Okay, x3 is now, this is a 6, this is a, let's say, 3. Let's say this is a 3. Okay, this value is 3. Okay, this value is 6. x6, this is a 1, this is a 0, this is a 2. Now you understand now, this is the new value. Let's say we are representing this as a y of yn as equals to f of 3n. So it becomes, y0, okay, y1, okay, y2 and y3. In a similar way, this is the y -1, this is the y -2. Am I right? So you can understand it like this. So this is the 0 at 2. Okay, at 3 it is again 0, and so on. Again, this is the -1, at the value is -2 is 3, and -2 the value is 0. So the signal is decimated. You can see when we, let's say, I'm smalling the screen. I'm also decimating the screen, So when you see this, the signal from, we can compare the signal from this to this, will occur that when you multiply with the 3, with the n signal, when let's say alpha or 3 is there, so it means you have decimated, you have eliminated 2 signals in between this first 0, 1, 2, 3. So you have eliminated 2 signal in between the 3n. If we are taking the 5, then you have to eliminate the 4 between the them. Okay, from 0 to 5 you have to eliminate the 4 signal. Okay, and just to representing. So now in the basis of this, you can now represent clearly at 0 is a 6. Okay, and if it is a 3, then the signal is remaining, and this signal is remaining. Otherwise, all the signal becomes, because 6 is 0. So it is a multiplication, 0, 3, 6, 9, and all the electrics at that. Okay, so you can representing the signal like this. So this is the meaning of decimation. Okay, so we have already written the decimation is nothing but the process of reducing the signal length. We are taking the reducing the signal length by discarding the signal, discarding the signal. Okay. Now come to the next part, that is the interpolation. And the interpolation signal, just it is a process, you can write it here, process of increasing, where we are reducing the signal by discarding something, here process of increasing. So how it will increase? The signal length. How the signal length is increased? By inserting 0. By inserting 0. By inserting 0 between signal samples. Okay. So here we are discarding the signals. In the case we're discarding the samples, here we are inserting the zeros in between the samples. Let's say how it will occur with the same example. Let's say this is the example again, x of 0. Okay. Now the question I am taking is, let's say x n y n is equals to x of n by 3. Okay, x of n by 3. So when you take the problem, so y, how it is solved? So y 0. So x n is, we have taken 0. So this value is 6. When y 1, so x 1 by 3 is nothing, 0. Okay. Y 2, x 2 by 3 is again 0. However, y 3, that is the x 3 by 3, this is the 1. Okay, and x1 is nothing but the 5. Okay, so x1 is nothing but the 5. Okay, you can find more signal y4. How y4 can be calculated? So x4 by 3. Okay, so 4 by 3 is 0. y5, x 5 by 3, 0. y6, so x 6 by 3 is the 2. Okay, this is the x2, and x2 is nothing but I think 4. Clear? y7, x7 by 6, 0. y8, x8 by 6, 0. y9, x9 by, sorry, this is a 3, my mistake, 9 by 3, 3. x3, and what is x3? The value of x3 is, the value of x3 is 3. Okay, value of x3 is 3. Okay, and we have taken x4 also. Yes, x4 also. So just you can write here y10. y10 is x of 10 by 3, again 0. y11, okay, x11 by 3, 0. y12, okay, so this is the, sorry, you can write the 12 by 3, this is a 4. So x4 is, x4 is, x4 is 2. x4 is 2 and x5 is 1. Okay, x4 2 is 2. In similar way, you can find y13 0, y14 0, and y15 you get 1, because it is a 5 by 3. In similar way, you can take the mirror image on the left hand side. So now draw these things on the plot, just to plot these things. Okay, see, this is the 0. This is the, at instant x equal to 0. The value is 6. Okay, what is the value? y1 0, y2 0. Again we will 3 by 3 is 5. This is a 6. This is the 5. Okay, this is the 5. Then 0, then 0, then 4, then 0, then 0, then 3. Okay, this is a 4, this is 3, then 0, then 0, then 2, 0, then 0, then 2. Okay, and then 0, then 0, then 1. Okay, and baki sub 0. In similar way, here also you can, so we are inserting the 0 in between the two signals, okay, and this property is known as the interpolation, right? Interpolation. So With the help of this, we can draw. Okay, so this is the case. So this is the interpolation. Interpolation, very important, very important. Okay, so since we are inserting the 0 in between the two signals, okay, in between the two signals, that depends on the value we are giving here. Okay, that value, by which factor we are just interpolating the signals. So since we are inserting 0, so therefore this interpolation method is known as zero interpolation. Okay, is now. So I think you understand these things. I'm coming to the next part. We have, okay, so let's say I'm taking one example for your better understanding. Let's say 1 2 8 4 6 is given. Okay, an arrow is here. Now the question will asked by your teacher, just decimate the signal by 2. It means you are giving n equals to 2n. So how will you do? Just you have to remove one, discard the one samples in between them. So one signal means just isko chhod do, isko 186. 186 is your now decimated signal. Now let's say I'm saying just to interpolate the same signal, just interpolate the signal, interpolate the signal, okay, by n by 2. What will you do? Just to put the 1 0 in between the them. Okay, so this one becomes your interpolation property. Okay, let's the same and try to see, do you get or not. First to interpolate by n by 2, right? So I will do 1 0 2 0 8 0 4 0 and 6. Now just decimate by n 2n. So how will do? So just you have to ignore 1 2 8 4 6. You will again retrieve the same signal. So it means you can conclude, conclusion is here. You can find out, first to decimate, then interpolate. You can't able to retrieve the main signal. However, when you first to interpolate and then decimate, you are able to retrieve the signal. Okay, so we can write the decimation is indeed the inverse of interpolation, but the converse is not necessarily true. So this is the case. It is a very important. When you handle the digital signal processing, this property will use at the time of the filter design. Okay, so next is the time reversal property, and there is no problem in the time reversal. You have already studied in the continuous time signal. Just to have take the mirror image from left to right and right to left. Okay, so this operation is known as folding. Okay, or you can say a reflection. Okay, reflection, right? Or you can say simply the time reversal. So we have already seen, so I'm not going to the detail, x, and you can represent the xn is by x of minus n, nothing else. Okay. So just reversing the signal. Okay. So just take you can say take the signal by reflection about n equal to 0. n equal to 0 पे है आपका, उसको इधर कर दो, इसको इधर कर दो, then we got the reversal property. Okay. So we have already seen some example of the combination of the signal. Okay. So I'm just giving and try to solve it by yourself. Okay. Let's say xn, let's say xn is, this is the homework for you. Let's say xn is equals to 1, 2, 3, 4, 5. Let's say 6. Simple example I'm taking, and the arrow is marked here. Okay. So now you have to sketch the various problem. Yn is equals to, let's say, xn minus 3. B problem I have taken yn is equals to x of minus n minus 2. So first shifting is there, then folding is there. Then yn is equals to, let's say, x simple xn plus 2. Then the problem, let's say yn is equals to x of 2n. Just we are interpolating or decimating the signal. Okay, decimation of the signal. E is the, let's say, yn is equals to x of minus n, let's say we have taken, and yn is equals to, let's say, x of minus n plus 1 is there. Okay, let's say yn is equals to x of 3n minus 1. So try to sketch the signal, and check, verify it either you are able to solve or not. So we already have seen the unit step and the unit step signal and the ramp signal in the case of the discrete time signal. So we are representing these things into the discrete time signal. So unit step signal is nothing, un you can represent. So 1 for n greater than equal to 0 and 0 for n less than 0, right? So you can write like also this 1 1 1 1 1 1 1 and so on, and arrow start from this, because this is n equal to 0, and from n less than 0 the all value is 0, right? So this is the case. Now take the unit impulse signal. We already have discussed these things in the continuous time signal in more details. So I'm just here introducing by the definition. Delta n is 1 for n at n equal to 0. Otherwise this is the n not equal to 0, right? So how it will represent? How it will be represent? Here will represent 0 0 0, like 0 comma 1 comma 0 0 0 0 and like this. Okay, like this. Is it clear? So this is the problem. Now when you talk about we have 2 minutes. When you talk about the property, we have already discussed in the time duration times continuous time signal, property of impulse signal. Okay, so we already have seen delta n, delta t is the integration. Now we are writing these things in terms of this term. Okay, un minus 1. We already done. So I'm not going to proof of this signal. If you require, just you can ask me. Okay, you can ask me. We have also seen the second property, that is the multiplication property by xn into delta xt delta t, okay, or xt delta t minus t naught. Here I am taking this property. So you can simply k na, delta n minus k, same property, delta t xt delta t minus delta t minus t naught. So this will give the x t naught delta t minus t naught. Okay, so same property we have applied here, right? Okay, so next is the next you can write here summation of k is equals to minus infinite to infinite delta k, or you can say we have already seen all in the terms of integration these things in the case of the the unit step signal. So this is the 1, this is the 0 for n greater than equal to 0 for the 0, right? So this is the case we have already done. So last property of the shifting property that we have done in the case of the integration xt into delta t minus t naught, we have already done. So with the help of this property, just we writing this, we are representing the same property in the discrete time, xn into delta n minus k. It is xk, nothing else, just the xk. So you can solve these things, or you can prove these things with the help of that concept again. And if you are not able to solve, just to ask me, I will give you the reference of the book, and I otherwise the you can Google also, or you can ask me also, right? So these are things. Now I'm leaving the class, and from next class, okay, uh, I have already 10-minute delay because I have to cover the signal up to the periodic and aperiodic signal for the discrete time, as well as the energy and power, energy and I'm lagging, these two topics in this week because of the network issue yesterday, and your class 50 minutes I invested in your class for the waiting. So this week I have to cover this point up to this point, but unfortunately I am not able to cover. However, we will start these things from the next week. Okay, so tomorrow is your the quiz. Meanwhile, I will record the lecture and try to upload the lecture so that this topic can be covered, and we will start with the fresh uh, topic. So thank you very much.